Hello and welcome to absolute value inequalities. Today we're going to continue our journey with absolute values, but we're going to do inequalities and not equations. So if you take out your notes and a calculator and a pencil, we'll get started. You don't need to write this down, let's just remember. Absolute value, what does it mean? It means the distance a value is from zero, how far I am from zero. Yesterday we worked on absolute value equations. They look like this. The absolute value of 2x minus 1 is equal to 5. What did we say? This had two solutions. So the expression needed to be equal to 5 units away from 0. Remember, that could have been 5 or negative 5 because it was a distance from 0. So an absolute value inequality, what is that in compared to an equation? Well, an inequality is going to have the greater than sign or the less than sign. And so my question is, how does this change my approach to solving the inequality? How is it same and how is it different? Well, they do have some similarities, but they do have some differences. So we're going to go ahead and the next couple of slides, I just want you to think. I want you to follow along my process and I want you to think. And then I'll have you do 3 examples at the end of the video. So here we go. The absolute value of x minus 2 is less than 4. Let's think about what that means. This means the expression x minus 2 is located at a distance of less than 4 units away from 0. So less than 4 units away from 0 is either 4 and lower or negative 4 and higher. So it has to be greater than negative 4, but it has to be less than 4 for it to be in that region of being 4 units away from 0. So how would I set up this inequality? Well, the inequality that I would use to represent this region would be negative 4 is less than x minus 2, which is less than 4. So it has to be less than 4 and greater than negative 4. It has to be somewhere in between this region. So then what we do is once we make our inequality, we take our inequality and we solve it. So I'm going to add 2 to all 3 sides, and I get negative 2 is less than x, which is less than 6. Now I take and I graph that on a number line. So I'll just do my number line over here to the left, draw my number line. I find 0. I'll go by 2's since we're going to 6. And it says less than, that says less than, so it's an open circle at 2. This also says less than, so it's an open circle at 6. And then where does x fall? In between. And remember what we talked about. In between means we'll shade in between our two values. So the solutions of this inequality, absolute value inequality, is negative 2 is less than x, which is less than 6. Okay, now what if I change my absolute value to a greater than or greater than or equal to? So this one says 2x plus 1, the absolute value of that is greater than or equal to 3. Well, let's think. What does that mean? This means that the expression 2x plus 1 must be located a distance of 3 or greater, because it's greater than 3. So 3 greater than 3 or less than negative 3. So it can be located all the way over here or there. Or, see the word or. Remember the compound inequalities that we worked with on Monday that were ors? This is an or. So if I want to write the inequality that's going to make this expression work, I'm going to take 2x plus 1, and that's going to be less than or equal to negative 3. Or I could have the inequality 2x plus 1, which is greater than or equal to 3. And then what I'm going to do is I'm going to solve each one of these inequalities. Now I don't get to do one or the other. Remember, I have to do both. So I'm going to do this one over here, subtract 1 from both sides, divide by 2, and I get x is less than or equal to negative 2. Or I can subtract 1 from both sides. 2x is greater than 2. X is greater than or equal to 1. So my choices are x either is less than or equal to negative 2 or x is greater than or equal to 1. So when I draw that on a number line, what's that going to look like? Well, here's 0, here's 1, here's negative 1, negative 2. Close circles because it's greater than or equal to. And then this inequality says x is less than or equal to negative 2. Less than is left. X is greater than or equal to 1. That is going to go right of 1. And these are all the possible solutions that can work. So greater is or. Okay, so now let's practice a couple to make sure that we have this down. So I have my first example, 4x plus 5, the absolute value of that is greater than 13. So we're going to solve it and then graph the solution. But let's first think what this means. It says greater than 13. So it's a distance of greater than 13 away. So here's 0, here's 13, here's negative 13. It has to be a distance of greater than those. So it has to be on this side of 13 or it has to be on the left side of negative 13. So what I would do is then I would say because it's an or, I would make my two inequalities. First is 4x plus 5 is less than negative 13, or 4x plus 5 is greater than 13. So I set my expressions equal to those two possibilities, and then I'm going to solve each one of those inequalities. So I'm going to add 5 to this side and to the right. 4x is less than negative 8. Divide by 4. X is less than negative 2. And then I'm going to do this one as well. Subtract 5 from both sides. X is greater than 2. So the answers are x is less than negative 2 or x is greater than 2. So how would I graph or sketch the solutions on a graph? Draw a number line. Here's negative 2, here's 0, here's 2. Open circle on both. Greater than 2. And, oh, I made a mistake. I'm so sorry. I should have subtracted 5 over here instead of adding 5. So these are wrong. I apologize. Just erase the right one. So subtract 5 on both sides. 4x is less than negative 18. X is less than negative 18 over 4, which is negative 9 halves. I was just making sure you guys were all paying attention. Okay, so now we'll graph it. So I have x is less than negative 9 halves or x is greater than 2. Okay, so here's 0, here's 2. Sometimes it pays to know that you're doing something wrong when it doesn't work out quite right. So then negative 9 halves is about 4.5. Negative 4.5, so that's about right here. Now I want to always make sure that I put that on the number line. Negative 9 over 2. Okay, and then greater than 2, open circle, greater than 2, and then less than negative 9 halves. So those are my two answers. It would be greater, so it's an or, so the arrows go in opposite directions. Okay, let's try another one, just because I messed you up on that last one. So absolute value of x plus 4 is greater than or equal to 6. So greater, again, greater. Here's 0, here's 6. It has to be greater than 6 or equal to, so it's a closed circle. And then it has to be, greater to on the other side. Well, greater is actually less than. So I have an or again. So I'm going to write out my two inequalities. And when I do that, I'm going to get x plus 4 is greater than or equal to 6. That's one possibility. Or x plus 4 is less than or equal to negative 6. And so then I subtract 4. and I get x is greater than or equal to 2. And then I subtract 4. Oh, I did it right this time, thank goodness. And I get x is less than or equal to 10. So that would be my the two solution inequalities. And then how would I sketch that on a number line? So then to sketch it on a number line, it would look like this. I would have closed circles at negative 10 and 2, and 2 and greater and less than negative 10 to the left. And you should draw this number line and your answers in your notebook so that you can see what it looks like with these answers written and with the graph. Okay? So we're going to go ahead and do one more example, and then that'll be it for today. So solve this inequality and graph its solutions. The absolute value of 2x minus 7 is less than 1 unit away. So if I'm thinking about this, this is 0, this is 1, this is negative 1. I need to be less than 1 unit away. So I need to be between negative 1 and 1. That's where I need to be. So when I write this inequality, it's going to be an in-between inequality. So I take my expression, 2x minus 7, and it'll be less than 1, but it'll be greater than negative 1. And I write it as a compound inequality, 1 together. And then I will go ahead and solve this by adding 7 to both sides. 8 is less than 2x, which is less than, 6 is less than 2x. 6 is less than 2x, which is less than 8. Divide all sides by 2. 3 is less than x, which is less than 4. And so my solutions are between 3 and 4, not including 3 and 4. So then what would that graph look like? This is what the solutions of that graph would look like. The values would be open circle at 3, open circle at 4, and everything in between. And you should write down the graph with your solutions so that you can see what that graph looks like and you have an example. So remembering for tomorrow, looking ahead to for tomorrow, you may want to remember that when we solve absolute value inequalities, we're writing an inequality, we're writing a compound inequality. Either we're writing an or compound inequality, or we're writing an and compound inequality. So remember that when you come to class tomorrow. Thank you, and we'll see you then. Bye-bye.